Hello everyone, we are from Group 1. This video is, we are showing flash for separating toluene benzene mixture calculation. Let me introduce the meaning of flash distillation. Flash distillation is a widely used method for separating liquid mixtures by partial vaporization. Not only that, this process is based on differences in component volatilities typically carried out in a flash drum or column under controlled pressure and temperature. It is a simple, cost-effective, and energy-efficient method often used in a petroleum and chemical industries. Flash calculation is used to determine how a fixed mixture spills into vapor and liquid phases when partially vaporized, known pressure and temperature, using phase equilibrium concept. The objective of the project is to design a flash for separating mixture toluene benzene, to review the overall composition, operating pressure and temperature for separating the mixture, assuming that the reaction mixture is an ideal solution, and lastly, to calculate the moles of liquid, moles of vapor, liquid phase mole fraction, and vapor phase mole fraction. Process and composition condition that we use for our calculation is temperature 95.35 degrees Celsius, pressure 101.60 kilopascal, and we use toluene 0.5 molar and benzene 0.5 molar. For binary system, the composition can be solved by using Root's law. The assumptions are the mixture is ideal solution and 100% separation. The second is actively coefficient y equals to 1. These are the inlet streams, and for the outlet streams, the basis we put for this calculation is 1 kilomole per hour solution mixture into the flash column.
Based on this page, you can see that we are finding the normal boiling point or Tn average. Zt is the mole fraction of toluene, T, which is 0.5, and Zb is mole fraction for benzene, which is also 0.5, as this is our assumption stated earlier. The Tn toluene, which is the boiling point of toluene at 1 bar, or which is 383.8 kelvins, where the normal boiling point for benzene is 353.2 Kelvin. The Tn average is found to be 368.5 Kelvin, which is approximately 95.35 degrees Celsius, and will be used as our operating temperature for our flash column. Here, we are finding the saturated pressure using the Antoine equation. The constants for A, B, and C are found using the Appendix B from our Thermodynamics textbook. For both benzene and toluene, the Antoine equation is used, and each of their constants were found using the book. And based on our operating temperature, which is 95.35 degrees Celsius, P1 set was found to be 158.837 kPa kilopascals for benzene, while P2 set for toluene is about 64.365 kilopascals. Here, in this slide, we are calculating the bubble pressure and the dew pressure. Based on the slide shown, the bubble pressure is about 111.601 kPa kilopascals. As for the dew pressure, it's about 91.608 kilopascals. As our operating pressure is about 101.6 kilopascals, which is in the two-phase region, this proves that a flash calculation is able to be occurred. Here, we are finding both the K values for both benzene and toluene. K1, which is for benzene, is equals to P1 set over P, approximately is about 1.5633. As for K2, which is for toluene, is about 0.6335. Using the formula above, we are able to plug it in all the constants Z, K, and values in order to find the V, which is the vapor stream of the flash column. Based on this and iterations after few iterations, V amount to about 0.47663 moles of vapor. Using the mass balance equation where L plus V equals to 1, L, the liquid stream, amounts to about 0.52337 moles of liquid. As using the formula of the rearranged formula for finding Y, which is the gas mole fraction for both benzene and toluene, a value of 0.6162 moles of benzene gas, while YT for toluene is about 0.3838 moles of toluene gas were formed. As for the liquid stream, using the relation of XB and XT, XB for benzene, 0.3942 moles of benzene liquid were formed, where 0.6058 moles of toluene liquid were formed through this process. Thank you.
Next, after we calculate the value for benzene and toluene for mole fraction in vapor and liquid, we will draw the flash column as shown below. First, we assume the mole in for flash column is 1 mole per hour and it is equimolar mole fraction for benzene and toluene. And for the vapor mole fraction for benzene and toluene, which is 0.6162 and 0.3838. And while the mole fraction for liquid benzene and toluene, which is 0.3942 and 0.6858. Next, for the flash column calculation sample, we will do the balance for each benzene and toluene. So, we will do mole in equal to mole out, and each mole in equal to mole out, we will do the molar flow rate times the mole fraction, and then after we will do the simultaneous equation, we will get M1 is equal to 0.47663 mole per hour, while M2 is 0.52337 mole per hour.
Now, let's look at the PXY and TXY diagrams for the toluene benzene mixture. These diagrams are very useful to understand how the two components behave during separation. First, the PXY diagram shows the relationship between pressure and composition at a constant temperature. The temperature is fixed at 95.35 degrees Celsius. At this point, partial vaporization occurs. Some liquid turns into vapor, which is key in flash distillation. In this graph, it has two curves, one for the bubble point and one for the dew point. The area between these two lines represents a mixture of liquid and vapor. Next is the TXY diagrams, which shows temperature versus composition at constant pressure. The pressure is fixed at 101.604 kPa, slightly above atmospheric pressure. This helps because toluene and benzene form an azeotrope and are difficult to separate at normal pressure. Again, we have bubble and dew point curves. Both diagrams help us know how much of each component ends up in the vapor and liquid phases. This page shows the PXY table, which provides the mole fractions of toluene and benzene in both vapor and liquid phases at different pressures. These values are used to plot the PXY diagram. Now on this page, we have the TXY table. This shows how the mole fractions vary with temperature, again for both phases. These values were used to draw the TXY diagram.
So, for safety procedures, we need to ensure the chemical used are compatible with the flash column materials. Next, personal protective equipment such as Haziq long pants, closed-toed shoes and safety glasses or goggles are equipped. Next, follow the fire safety precautions.